In this section 5, risk attitudes. So I have mentioned earlier about the risk attitude, like risk neutral, risk averse, and risk seeking or risk loving in the last part of section 4. So this time we're gonna get more into details about these risk attitudes. So let's consider a gamble that with a probability P, you'll get WH dollars, and 1 minus P, you get WL dollars. So you can think about H here is a high and L here is low dollar amount and the high dollars amount. The expected value of this gamble is, expected value would be, yes, so P times WH plus 1 minus P times WL. Like you can think of it like, you know, like flipping a coin, right? Like, okay, you flip a coin, that it would be 50% chance that you get head and 50% chance that you will get tail, right? If you get, if 50% chance it turns head, and if it turns head, then you get $5. If it turns tail, it's another 50% chance. If it turns tail, then you get only $1, for example. Right? So what is the expected value of this game or this gamble? That would be 0.5 times 5 plus 0.5 times 1. That will be expected value of this gamble. A consumer is said to be risk averse if he or she strictly prefers receiving the expected value of a gamble to playing the gamble. Right? So receiving the expected value of the gamble, that means receiving the sure thing, the sure dollar, rather than playing the gamble, which is a risky action. Right? Because playing the gamble, you might win or you might lose. There is a probability associated to it. But if you choose to receive the sure thing, which is just the expected value that you compute here, you choose this amount rather than playing the game, then that means you are risk averse. For risk neutral, you will be indifferent between, you know, receiving the sure money of the expected value or playing the gamble itself. Risk loving, you would definitely prefer playing a gamble to receiving the sure money. Risk averse, if and only if U is concave. Risk neutral, if and only if U is linear. Risk loving, if and only if U is convex. It is a concave utility function, right? We have the BL and the BH. Obviously, it is the expected value of the wealth, right, of this gamble, because it's the chance of P that you will get the low. Let me see. I forgot what was it? P. I think that there was like a different kind of a little bit wrong notation going on here. So because we use this, it actually had to be another way around. It had to be P times WH. So I think I would just correct this. It would be PWL plus 1 minus PWH. Okay. So that it is consistent with this figure. So this EW here would be equal to P times WL plus 1 minus P times WH. Okay. And then you can see that, sorry, was some notation I made earlier. And you can see that if you draw the line connecting this, so this is EWL, this is this is UWL, this is UWH, right? And this is just this one is P times P times UWL plus 1 minus P times UWH. So this is EUW. Remember, the utility function is concave, whereas this point here is the utility of expected value. The utility of the expected value. Right. So as you can see that the interpretation is this is the true money, the expected wealth. Right? If you are offered, this is a risk-averse person because utility is concave. So this person, if he is offered this, expected value of the game, right? Then the utility value of this true money is equal to that point, equal to this. Yeah. When he compare, but if he choose to play a game, if he plays the game, right, then he could end up with this, or he could end up with this. If you compute the expected utility value of this game, right, this is an expected utility function. If you remember, expected utility function would be P times U to be 1, the U of the outcome of state 1, plus 1 minus P times the utility of the outcome in state 2, right? U to be 2, right? And that is exactly this one, exactly this. So it is very clear to see that the utility here is greater than the expected utility. Therefore, he would prefer to choose the true money over the gamble. Right? This is the expect because we don't know what he's gonna get. But what we can do is we compute the expected utility value of this and compare to the utility of the true money, in this case, which is expected of wealth. And since this one is greater than that one, so he will choose the true money rather than the gamble. This is just, the same figure. For the risk loving, we have a convex utility function. So instead, as you can see, do the similar application, but now it is very clear to see that expected utility value, right? So this is the expected utility if he chooses to gamble. This is how much expected utility that you expect to get. Versus if he is offered the true money, which is EW, then his utility with the true money, there is no expected value, right? But this is the utility of the true money, which is smaller than the expected utility value. Therefore, he would choose to gamble. He loves risk. A risk neutral doesn't matter, right? They are all the same. So sure thing, gamble, give them the same amount of utilities. So this risk neutral person or consumer would be indifferent between, playing the gamble or choose the true money.